Right, we've got the P4 international paper, Jan 2022, unused because it got leaked. And the question is actually about leaks, so good old Excel. Right, so water's flowing into a large container and leaking from a hole in its base. At time t seconds, the water starts to flow. The volume is modelled by this differential equation. So it's the rate of change of the volume. So there's 300 going in. So that's increasing the volume by 300. That's at plus 300. But it's also decreasing by something times V, some factor of V. It's something times V because the more water is, the faster it'll leak out. We've got to solve the differentiation equation to show that V is equal to that. Okay, so we've got the differential equation. We're going to separate the variables, and we can't add and subtract. We've got to multiply and divide, otherwise we're just getting all sorts of bother. So we're going to divide both sides by this 300 minus kV. I'll keep the dV over this side, but I want the t on the other side. So the dt, I'll multiply by that. It's really just 1 on this side now because I've divided by this 300 minus kV, and I'm going to integrate both sides. So the right hand side is just t. The left hand side, this is going to be an ln of 300 minus kV. But because if I differentiate this, I'll have to multiply by minus k. So I'll stick a minus 1 over k in front, and then I'll put a plus c on the other side. And then multiplying all by minus k. My constant will change, so I've called it d instead now. That d really is minus k times c, but it's just a number, just a constant. I haven't used a because they've used that in the question, so we use a different one. I need to say v equals, so I'll have to e both sides. So I end up with this, which I can write as e to the minus kt multiplied by e to the power of d. And this is still just a constant, so I'll call that b. Again, I haven't used a because they used it in the question. And if I rearrange it, so kv on the other side, I have 300 minus the b e to the minus kt, and then dividing by k, I can write like this now. That a really is minus b over k, but it's still just a constant. It's just a number. I just don't know what it is. Then it says, given that the container is initially empty, and when t is equal to 10, the volume of water is increasing at a rate of 200. And we're going to find the exact value of k. T is 0, b is 0. Putting this into here, 0 is 300k plus a e to the 0. That's just a times 1, so the a is minus 300 over k. So I can put that into here, minus 300 over k in for the a. And it says, which I can simplify to this. So here's my V, and it says the volume was increasing, so at a rate of 200. So when t is 10, dv over dt is 200. The dv over dt is still 300 over k, but this bracket, the one will go, I'll just put minus k in front, so it'll be k e to the minus kt. And that's going to be 300 because the k's cancel, times e to the minus kt. Put that equal to 200. And then multiplying by e to the 10k and divided by the 200, I get this. So k equals 1/10 ln of 3 over 2. Part C says, hence find, according to the model, the time taken for the volume in the container to reach 6 litres. Give your answer to the nearest second. So we need to say t equals. I'm going to leave it with k in, just to make my life a bit easier. So I'm going to rearrange it, put 6,000, 6 litres, 6,000 equal to this, and rearrange it. Multiplying by the k and dividing by 300, I get 1 minus e to the k, 6,000 k over 300, 20k. Taking this over the other side, the 20k over. Then do the ln's and divide by minus k. But I need to substitute the k in. So what I do, I put this in the calculator, the k value, get the decimal, and then do -1 over the answer, ln 1 minus 20th times the answer, and you should get 41.